Hello student, here in this lecture I will discuss example of root locus or how we will draw the root locus on graph paper. Okay, so root locus always root locus draw in the graph paper. Okay, so start our discussion. So take this example. A unity feedback control system has an open loop transfer function Gs equal to k divided by s into s plus 4. Draw the root locus and determine the value of k if the damping ratio zeta is to be 0.707. So let's see the solution. The root locus always start from open loop pole. So here in our system there are two poles, 0 and -4. So from this two pole root locus start. Okay. Second point is, as there is no open loop 0 in our system, therefore these two root locus terminate at infinity when k equal to infinity. Third is, as the number of poles is 2, the number of root locus branches n equal to 2. Fourth is, the root locus on the real axis between 0 and -4. Now we identify this pole in the plot. Okay, so see this is our plot. So this is our real axis and this is our imaginary axis. Here I have mentioned real, RE, imaginary, IMG. Okay, now we identify the pole and 0. Okay, so here in our system there are two poles. One pole is s equal to 0, that means this, and one pole is s equal to -4, that means this. And from these two poles root locus start. So in which way root locus start we will identify. Okay, so now we consider the point -4. So if we consider the point -4, now we identify the portion of the root locus. So for this we take the point -4. Okay, and see the right side of this point. If in the right side of this point there have odd number of poles and zeros, then this portion must be in the root locus. This part must be in the root locus part. Okay, so if we consider this point -4, then look at the right side of this point, then we see there is only one pole is there and this is odd number. So the root locus portion is in between 0 to -4. This portion is the root locus portion. Okay, and we know in our system there are two poles, and from this two pole two locus start. So one locus start in this way and another locus start in this way, because our root locus portion in between 0 to -4. Okay, now we identify the breakaway point. Okay, so for breakaway point we need to calculate the characteristics equation. So characteristics equation is 1 plus GSHS equal to 0. So here put the value of GSHS. In our system we consider unity feedback system, that's why HS equal to 1. Okay, so here only have GS value. So if we put the GS value in our characteristics equation, then we find k equal to -s square plus 4s. Okay, so finding breakaway point need to calculate dkds. That means we differentiate k with respect to s, and this dkds equal to, put dkds equal to 0. So if we differentiate k with respect to s, then we find dkds equal to -2s plus 4, and if this is equal to 0, then s equal to -2, and this -2 is our breakaway point. Okay, so here this is our breakaway point. Okay, now we identify this breakaway point in our graph. So see, this is our breakaway point, -2. Now we find the angle of asymptote. Okay, for finding angle of asymptote, first identify the k. We find the angle of asymptote by this equation, 2k plus 1 into 180 degree divided by p minus z. Here p, capital P is the number of pole and capital Z is number of 0. Okay, and k is 0, 1, 2 up to p minus z minus 1. So if we put the value of p and z, then k have only two values, 0 and 1. Okay, so now put the value of k and find the angle of asymptote. So if we put the value of k, then our asymptote angle is 90 degree and 270 degree, because we have two pole, and from this two pole two root locus start, and that's why we have two angle of asymptote. Okay, now after finding asymptote angle, we find the centroid, because asymptote intersect at a point on a real axis, and that point is known as centroid. Okay, so centroid, here centroid I have mentioned centroid by x, and this x equal to sum of poles minus sum of zeros divided by p minus z. Here we consider only real parts of pole and real parts of 0. Okay, so here put the value of pole and 0. We calculate our centroid is -2. Okay, now we identify this angle of asymptote and centroid in our graph. Okay, so see, this -2 is our breakaway point also and our centroid also. Now draw the angle of asymptote. Okay, so there are two asymptote. One asymptote have angle 90 degree. This is our one asymptote, and another asymptote is 270 degree. Okay, clear? Okay, so see, we have two pole, 0 and -4, and from this two pole two locus start, and locus started from 0 in this way and start from -4 in this way, because root locus portion is in between 0 to -4. Okay, and -2 is our centroid. So from -2 we draw asymptote by angle 90 degree and 270 degree. So asymptote drawn by dotted line. Okay, and this is 90 degree, and another asymptote angle is 270 degree, that is this one. So angle is this. Okay, so asymptote always drawn by dotted line, and locus start from 0 and -4 in this way, and they meet at breakaway point, and our breakaway point is also -2, that is this. So these two locus meet at breakaway point at -2, and from this -2 they leave the real axis and follow our asymptote. Okay, so one locus move in this way. We take another color. So one locus start from -4 and reach -2, and from -2 leave the real axis and follow the asymptote in this way, and another locus start 0 and meet at -2, reach at -2 and leave the real axis and move in this way, that means move in this way. Okay, and this is our k equal to infinity, this is -infinity, and this is our k equal to +infinity. Okay, So I remove this all highlighted and see. Okay, clear? Now we calculate the value of k. Okay, so how we find the value of, we'll find the value of k. So see, with the data calculated in steps 1 to 7, the root locus plot is this, and given zeta equal to 0.707. So we have already known zeta is equal to cos theta and cos theta. So put the value of zeta here. So if we put the value of zeta here, then cos theta is equal to 0.707. So from this we calculate theta. So theta is 45 degree. Okay. So from this, so see, from the origin, this is our origin. This is our origin. Okay. So from the origin, a line at an angle 45 degree. Okay. This is our 45 degree. Okay. So see, from the origin, a line at an angle theta equal to 45 degree is drawn like shown in figure, which intersect the root locus plot at s equal to minus 2 plus j2. This minus 2 plus j2 point we can find by we can find from the graph, or we find from the graph. Okay. So from the origin, a line at an angle theta equal to 45 degree is drawn as shown in figure, which intersect the root locus plot at s equal to minus 2 plus j2. As the point s equal to minus 2 plus j2 lies on the root locus, the following equation, that means magnitude condition, should be satisfied at s equal to minus 2 plus j2. Okay. So magnitude condition is mod of GSHS equal to 1. Okay, so see, this is our magnitude condition. This is our magnitude condition. So here put the value of GSHS. So here if we put the value of GSHS, then mod of k divided by s into s plus 4 equal to 1. Now here we put the value of s and calculate k. So after putting the value of s, we find k equal to 8. Okay, so in this way we find k. Okay, clear?